today we are going to begin on chapter 13, nitrogen and sulfur theory. Okay, so for this one, right, we are going to explain the lack of reactivity for nitrogen. Okay, we're going to explain. We're going to learn more a bit about ammonia, ammonium ion, and how it's often formed, and the displacement of ammonia from its source. Okay. Next, we're gonna learn more about ammonia and nitrogen compounds, and this one we're gonna talk about environmental consequences, and also about nitrogen oxides of nitrogen. Okay. Next, we are gonna talk about the formation of sulfur dioxide and the role of sulfur dioxide in acid rain. Okay, so this chapter is a bit more factual. So nitrogen gas, very common, reason unreactive, strong triple covalent bond. So therefore highly relatively inert, relatively lah. So because of that, right, for it to react, right, nitrogen gas can only react under very harsh conditions. Okay, under very harsh conditions. So the two ways a nitrogen react is when, for example, under high temperature and high heat, to which lightning can provide. Yeah, lightning can provide. So you form nitrogen monoxide, and nitrogen monoxide can form nitrogen dioxide. Eventually, when reacts with water from the air, form nitric acids. Okay, or nitrous acid. Okay, so ammonia, no need to say. We often use it to react with nitrogen gas under high temperature, high pressure to give you ammonia under what we call Haber process. And ammonia, upon reaction with acid, happily form ammonium ion. Okay, and ammonia is also a weak base because can dissociate water to give you ammonium hydroxide. So can easily form ammonium ion, and it's also a weak base. So fertilizers, because you must remember, amino acids, which is one of the building blocks of molecules, has a lot of nitrogen inside there, and usually plants needs nitrogen. So because in order for the plants to grow, one way we assist the growth of plants is through fertilizer. So they just need to provide them with a lot of nitrogen type of compounds, ammonium chloride, ammonium nitrate, ammonium sulfate, and ammonium phosphate. And a lot of times what some big plant or farming what they do, right, is they keep a huge amount of ammonia and nitric acid, so whenever they want, they can form ammonium nitrate themselves to fertilize their own farm. Ammonia can be prepared from the lab. If you want to prepare it, is by using ammonium chloride with sodium hydroxide. You release a lot of ammonia, or ammonium chloride with calcium hydroxide. Any ammonium you react with an base, you will get your ammonia gas. So one of the uses of ammonia, the reason why Haber process is a major thing, is because we want to produce a lot of fertilizers to promote the growth of plants. Can make a variety of fertilizers: ammonium sulfate, ammonium nitrate, urea. Another one is actually to produce what we call nitric acid. This is what we call the Oswald process. Okay, again, ammonia reacts with oxygen, form nitrogen monoxide. This part is an equilibrium process to which nitrogen dioxide reacts with oxygen and water to give you nitric acid. Nitric acid can be used to make explosive TNT and a variety of other stuff. Okay, so ammonia has a wide variety of uses, not only for fertilizer, also together with other stuff. In fact, Haber process was created because they want to use it to create explosives during one of the wars. Okay, now unfortunately, there is a problem with using nitrogen-based fertilizer because you realize your ammonium and your nitrate is very soluble. Unfortunately, people overused it. When you use too much of this one, right, what happens is the excess goes into the soil and eventually travels to the rivers and lakes. As you remember, you also got rainwater coming in. Eventually, all the water will lead the ammonium and nitrate somewhere, enter back into river and lakes. Unfortunately, inside the lakes also got something called algae. And algae also grows because receive a lot of nutrients from the fertilizer. It blooms. Unfortunately, when the algae blooms, okay, algae bloom is okay, but excessive growth causes what happens? Causes your now the algae, right, to cover up on the very top and around a little bit inside, all around the water, the algae overpopulated, causes the water to have less oxygen, not less oxygen, less nutrients and less stuff inside there. What happens is other marine lives and plants die off because of that. This process is what we call eutrophication. Okay, so remember, fertilizers is good. It causes plants to grow. Unfortunately, when you have excess already, right, the excess enter into the rivers and lakes. It causes algae to bloom unnaturally, and some of the algae, right, even grow on the very surface of the water, block sunlight from entering into it. So that also causes disruption to the marine life and plants. This is what we call eutrophication, the death to marine life because of excessive growth of algae. Imagine an algae is part of the life cycle. But when your algae becomes too big or too much, right, it steals resources from other marine lives. Okay, and that is eutrophication caused by the excessive use of fertilizers. Very important, come out numerous couple of times already. Okay, yeah, oxygen is depleted. Okay, because when algae blooms on the surface, prevents sunlight, the plants here die. Less oxygen in water, less oxygen for the marine animals. Okay, yeah, eventually when oxygen levels reach a point where no life is possible, meaning that so and few oxygen, eventually all other organisms die. Okay, nitrogen oxides. Okay, at the end of the day, you must remember now nitrogen can only react with oxygen under harsh conditions like lightning. It also occurs at one more place, your car engine. Because in your car engine, it is when it is high temperature and high pressure. So what happens is that first your car reacts with nitrogen dioxide and nitrogen reacts with oxygen to form nitrogen monoxide, and they can further react from nitrogen dioxide. If you release this to the air, where is it? Okay, if you release this to the air, it can do two stuff. One, reacts with the water in the air to give you nitric acid or nitrous acid. Second, the more important one, it catalyzes sulfur dioxide to happily form sulfur trioxide. So some of the sulfur dioxide from your burning of your car fuel is now released already. It can catalyze it by changing sulfur dioxide to sulfur trioxide easily. Then sulfur trioxide will react with water to form sulfuric acid in the air. Okay, so those are the two effects. It can one become nitric acid by reacting with water in the air, or catalyzes the formation of sulfur trioxide, which also in turns later form sulfuric acid. Okay, so in order to prevent that, most of the time we put in a catalytic converter at the very exhaust part there. What we do is that because we don't want carbon monoxide and nitrogen monoxide, so the platinum catalyst will take these two and react them to form carbon dioxide and nitrogen, or it can convert nitrogen dioxide back to nitrogen and oxygen. Okay, so this is what catalytic converter does. If your car engine burns and release carbon dioxide and water, still okay. Unfortunately, it releases a bit of amount of carbon monoxide, pollutant, toxic, nitrogen monoxide, nitrogen dioxide, environmental pollutants. So we try to minimize this by putting inside there a catalytic converter. Okay. Now, sulfur is not much that's to say about it. Often exists as solid S8 yellow color. Okay, yellow color solid. If you heat it up, it becomes liquid. Sulfur dioxide looks like this. Sulfur trioxide looks like this. Both of these colorless gas. Okay, now the thing about sulfur, right, is that most of the time from the volcanic activity of sulfur dioxide, it's okay. But there's an excess of sulfur dioxide because we use up a lot of fossil fuel. We burn a lot of them in the car engine. And because of that, we release a lot of sulfur dioxide in the air. Remember, so how come got? Because your petrol there, inside your petrol there, the gasoline, got a small amount of sulfur inside there. So when you heat up and burn your fossil fuel, you actually will take the sulfur and react with oxygen to form sulfur dioxide. Unfortunately, sulfur dioxide, upon catalysis of nitrogen dioxide, forms sulfur trioxide. Now, problem with sulfur trioxide is that your sulfur trioxide can react with sulfuric acid, can react with water to form H2SO4. Your previous nitrogen dioxide can form nitric acid. These both contributes to what we call acid rain, rain that is more acidic than usual. Imagine a rain that is 5.5, 4.5 the pH. This type of rain is too acidic already. Too acidic, what's the problem? It kills off plants. Your plant can only grow in a steady amount of pH. Too acidic cannot grow. So most of the time, what people do is they try to apply some base, lime, calcium hydroxide or calcium hydroxide to the soil. So one thing it will kill off is kill off plants. So we try to apply, if the soil too acidic, we apply calcium hydroxide. Rivers, streams and lakes, what's the problem? A lot of them is not that acidic. When your marine life is too acidic of a water condition and environment, they will die off. And last but not least, corrosion of building and statues, because one of the main components of the building and statues is calcium carbonate. Upon reacting with too acidic of a rain, decomposes. That's why corrode. Okay. Now, so in order to reduce sulfur dioxide emission, what a few people try to do is petrol and diesel try to keep the amount of sulfur there as few as possible. Before they pass you the gasoline, try to remove the sulfur from there. Another way is that if let's say you are a factory, you have no choice but you produce sulfur dioxide. On top of the chimney there, before we release the gas, we put in a calcium oxide there. Okay, the calcium oxide will react with sulfur dioxide and half oxygen to form calcium sulfate, or use catalytic converter to remove in the car to remove the nitrogen monoxide or nitrogen dioxide that catalyzes sulfur dioxide to sulfur trioxide. Okay, and these are some of the ways we try to prevent or reduce SO2 emission. Rain cannot be too acidic, if not we have a lot of harmful effects. Fertilizers are good but cannot overdo, if not also have harmful effects. And yeah, that is about it only. So far, I would just emphasize this again. The nitrogen and ammonia one, that part is okay. If ever this question they like to ask a lot more, please focus on this, which is I would recommend focus more on this part. Environmental consequences of nitrate fertilizers uncontrolled use. Eutrophication is a popular question. How does nitrogen oxide form in your car and gets removed? Also another type of popular question. Last but not least, okay, how does nitrogen monoxide or dioxide catalyze the formation of sulfur trioxide from sulfur dioxide? And the roles in acid rain and the environmental consequences, those one also is very important. So these are some of the main factual stuff you have to remember. With that being said, thank you very much.